Hello, my name is Konstantinos Maliatsos. I'm an assistant professor in wireless communications representing University of Piraeus, and I'm here to present you the project iSEE-6G, that is integrated sensing energetic communications for 6G networks, where I have assumed the role of the technical manager. So here are the basic details. It's a B0102 project. Started on January with 36 months of duration. IMST is the coordinating partner from Germany. Okay, so in the iSEE-6G consortium, we have all competencies needed to successfully cover the proposed research and innovation items. It brought together a mix of 12 partners from 8 different countries. A significant part of the consortium is research institutes and with 5 highly acclaimed academic organizations, 4 technology SMEs, and 3 heavily involved industrial partners in 5G and beyond 5G and 6G communications. I will say that iSEE-6G is not yet another integrated sensing and communications project, but we introduced the concept of joint communication, computation, sensing, and power transfer. So we have a new paradigm that we have proposed. And on the figure here, we present a conceptual environment for iSEE-6G that includes the main use cases that we are considering and designing now in our work package with detail and accuracy. So we are talking about a self-free architecture following the ORAN paradigm in a network with a varying service and service placement and with different requirements, supported from intelligent arrays, intelligent surfaces, and also, as you can see here in the figure, UAVs. We will come back in the use cases in the different slides. But generally, iSEE-6G will investigate the concept of joint communication, computation, sensing, and power transfer from the antenna, the physical layer, to the radio access network and to newly enabled services. So in a nutshell, iSEE-6G proposes the investigation, definition, and development of a joint communication, computation, sensing, and power transfer paradigm, which is accompanied with all support elements of the proposed solution for 6G future revolutions by integrating, exploiting, and supporting 6G key enabling technologies like intelligent surfaces, like UAVs, like different frequency bands, FR2, FR3. And the framework of iSEE-6G includes a GCCSP-oriented novel passive and active antenna solution with intelligent reconfiguration capabilities, a GCCSP optimized physical layer design, including waveform design, new frame structures, new sharing and scheduling schemes, channel modeling, different architectures for beamforming and hybrid beamforming, GSSCP cross-layered schemes under the new capabilities that we have with sensing and power transfer, mainly, and communication, of course, and GCSSP implemented system-level solutions. So the main research axes and domains of iSEE-6G is, of course, communication in terms of sending information signals from different parts of the network to others, sensing, the ability to detect and track objects and motions in the environment, but also we have also wireless power transfer, or generally power transfer and harvesting with the technology that allows the use of electromagnetic fields to harvest energy, to be able to transfer energy, and also the provision of computational support through offloading at the edge in order to facilitate complex or energy draining functions, as well as improve the results through cooperation and fusion. So in this case, we put them all in the mix and try to find optimal best solutions and identify specific trade-offs. The set of functionalities is here in the figure. In the lower part of this figure, you can see the strands of development and research for iSEE-6G. So we have radio propagation and antennas, we have the physical layer design, waveform pre-coding, beamforming, we have system level evaluation, scheduling and multi-user access, MEC supported positioning and sensing, and also services that are generally include public protection and disaster relief services and emergency responses. This approach considers an end-to-end, as you can see here on the right, from the physical medium to the application. And we tried, let's say, starting from the channel characterization to be able to perform, to provide a full system up to the application. Now, as far as the UAVs are concerned, it is a central part of iSEE-6G in terms of the use case. So the UAVs have multiple roles, will contribute to the self-free 6G paradigm. They will be used also as targets or sensors for joint communication and sensing for active and passive sensing schemes, support the next generation of backscattering communications, energy harvesting and ground transfer as means for wireless charging, supported mainly in some cases by drones. The means for designing energy efficient communication systems and green communication overall, and as flying mobile edge computing devices, servicing low-end devices under the concept of massive IoT. Now, in order to control and regulate the beyond line of sight UAV mobility, the concept of aerial corridors is also envisioned. And these corridors, you can see it as a space where multiple swarms of drones will move. And in this case, the sensing part from above to the ground and the ground to the corridor becomes quite critical in order to be able to provide autonomous operation and safe operation, and also provide new services. Now, iSEE-6G proposes a holistic layered architecture from radio channel to the UAV application, as we said, and this approach will be verified or validated through simulation initially. We will build our own simulators, of course, and then we have laboratory clean room experiments and software-defined radio laboratory being set up in order to be able to perform the initial validation, and then 2 large-scale proof of concept in testbed facilities will be performed. So the objectives in let's say very brief list.
So you have 1 minute left. So
okay, thank you. Yeah. To measure and characterize the joint communication sensing channel, to design waveforms, to investigate the configurable surfaces, investigate beamforming schemes and network MIMO schemes, to investigate new framing schemes and new scheduling multiple access, and moving to higher layers, investigate system level energy efficiency, develop wireless casting schemes to support sensing and power related information exchange, a MEC-enabled system for enhanced positioning, AI-enabled collaborative positioning algorithms, and the integration of services for emergency response. So the proof of concept experiments mainly will be, we have the IMEC testbed of the highway, the 5G enabled highway, and also we have from Orange, Romania, a testbed for 5G. We will be able to use software-defined radios to implement our new waveforms and new designs in a fully controlled environment. And also we have available a fleet of drones, of heavy-duty drones, be able to carry also radio equipment and perform tests. So that's all for iSEE-6G. Thank you very much, and very